In the early years of the space age, humanity believed Venus might be Earth's twin, similar size, similar distance from the Sun. Some scientists even imagined oceans beneath its clouds. But behind that thick white veil was a world far more hostile than anyone expected. This is the story of how the Soviet Union tried to reach that world and what Venus did to their machines. What this documentary explores. This documentary examines the Soviet Venera missions, a decades-long effort to land machines on Venus, collect data, and send images back to Earth. It was one of the most ambitious planetary exploration programs ever attempted. It was also one of the most punishing. The Cold War context. During the 1960s, the Cold War was at its peak. The United States and the Soviet Union were locked in a global competition, not just on Earth, but in space. America focused its resources on the Moon. The Soviets chose a different target. If the Moon could be conquered, Venus would be the ultimate proof of technological power. Why Venus looked promising. From a distance, Venus seemed familiar. It orbited close to Earth. Its size was nearly the same. Telescopes showed a planet completely covered in clouds, hiding its surface from view. At the time, no one knew what those clouds concealed. For scientists, Venus was a sealed box. The strategic gamble. Soviet planners believed that showing Venus from the inside would be more impressive than landing on the Moon. If Venus had oceans, forests, or even unusual geology, the discovery would be historic. That belief led to a bold decision. Venus would become the Soviet Union's ultimate planetary challenge. The Venera program began. The spacecraft built for this mission series was named Venera, the Russian word for Venus. Engineers designed it to survive pressure far greater than Earth's atmosphere. But they were guessing. No one yet knew how extreme Venus truly was. A culture of secrecy. Soviet space missions followed a strict rule. Failures were not announced. Only successful launches were made public. Everything else disappeared into silence. This secrecy would later hide the true scale of how difficult Venus really was. The first attempt. In February 1961, the first Soviet probe was launched toward Venus. It never escaped Earth's orbit. The world was never told. Officially, it was described as a heavy satellite launch. Unofficially, it was the first warning sign. Early flyby failures. Later that same year, another probe was sent. Its mission was simple: fly past Venus and send data. 7 days after launch, contact was lost. The probe passed Venus silently and drifted into space, still orbiting the Sun today. A pattern emerges. Several more attempts followed in the 1960s. Some failed at launch, others lost communication mid-flight. Many never received official names. In space history, they are known as ghost missions. But the Soviets continued. A dangerous new approach. By 1966, Soviet engineers decided to try something more extreme. Instead of flybys, they would crash directly into Venus's atmosphere. The goal was no longer survival. It was information at any cost. First contact with another planet. When one of these probes finally struck Venus's surface, it sent no data, but history had still been made. For the first time, a human-made object had reached another planet. The real discoveries were still ahead. At this stage, the Soviets still believed Venus could be understood with stronger machines. But what happens when strength alone is not enough? The first real data shock. As Soviet probes began entering Venus's atmosphere, scientists expected difficulty. What they did not expect was total devastation. The data that came back did not describe a warm, cloudy, Earth-like planet. It described a crushing, hostile world. Venus was not hiding oceans, it was hiding an oven. The atmosphere nobody predicted. Early measurements showed Venus's atmosphere was not just thick, it was massive. Pressure near the surface was dozens of times stronger than Earth's, enough to flatten a submarine, enough to crush steel structures. Suddenly, every previous spacecraft design looked fragile. Heat beyond survival. Then came the temperature readings. Venus was hotter than Mercury, even though Mercury is closer to the Sun. Surface temperatures reached levels where lead would melt. Electronics failed within minutes. Lubricants evaporated. Metal weakened. Venus was not just hot, it was relentlessly hot. The cloud layer trap. As probes descended, they passed through thick cloud layers made of sulfuric acid. These clouds were not rain-like, they were corrosive and aggressive. Sensors degraded, signals weakened. Some probes went silent before ever reaching the surface. The descent itself became a battle. Venera 4, a partial breakthrough. In 1967, Venera 4 finally transmitted atmospheric data during descent. But there was a problem. The probe stopped sending signals far earlier than expected. It had not reached the surface. At first, scientists believed the spacecraft had failed. Later, they realized the truth. The atmosphere was far denser than their strongest estimates. Redesigning for the impossible. This discovery forced a radical change. Soviet engineers abandoned the idea of lightweight landers. They began designing pressure tanks instead of spacecraft. Thick shells, minimal electronics, no moving parts unless absolutely necessary. Every gram now served survival. Venus as a mechanical destroyer. Even with stronger designs, Venus showed no mercy. Some probes overheated before landing. Others were crushed silently. A few sent data for seconds, then disappeared. Each mission added knowledge. Each failure rewrote engineering limits. The moment of realization. By the late 1960s, scientists finally accepted the truth. Venus was not misunderstood. It was fundamentally different. Its atmosphere trapped heat endlessly. Its surface recycled nothing. Its environment erased machines. Venus was a planet that destroyed visitors by default. Why the Soviets didn't stop? Because now the mission had changed. It was no longer about finding life. It was about proving survival was possible at all. If a machine could survive Venus, it could survive anywhere. Transition to the next chapter. Engineers believed they were close. The pressure problem was understood. The heat was predictable. Communication windows were improving. All that remained was one final challenge. Could a camera survive long enough to show what Venus actually looked like? If Venus destroys everything that touches it, what would it take to steal even a single image from its surface? The first images ever taken on Venus. For years, Venus remained invisible, not because it was far away, but because it refused to be seen. Scientists knew the surface existed, but clouds blocked every telescope. The only way to know the truth was simple in theory and brutal in practice. You had to land on Venus and survive long enough to take a picture. The Soviet Venera program was the first to attempt this impossible task. Earlier probes had already proven how deadly Venus was. Most were crushed, melted, or silenced before sending anything useful. Still, engineers pushed further. Their goal was no longer long-term survival. It was seconds. In 1975, Venera 9 and Venera 10 touched down on Venus. For the first time in history, cameras were on board. But even this came with a problem no one could test on Earth. The cameras were sealed behind metal lens caps designed to open only after landing. If those caps failed, the mission would be blind. When Venera 9 landed, temperatures were above 460 degrees Celsius. Pressure was more than 90 times Earth's atmosphere. Then, the lens cap opened. For the first time in history, Venus looked back at humanity. The image was black and white, low resolution, grainy, but it showed something extraordinary. A rocky surface, flat slabs of stone, no oceans, no jungle, no mystery world, just heat-scorched geology under a yellow sky. Venera 10 followed soon after, confirming the view. These were not artistic photos, they were not detailed, but they were proof. Venus was real. Its surface existed, and it was far more hostile than anyone imagined. The cameras kept working, briefly. Within minutes, internal temperatures rose beyond safe limits. Electronics failed one by one. Signals faded. The probes died exactly as expected. But those final images changed planetary science forever. Venus was no longer a theory. It was a measured reality. And the cost of seeing it, even once, was total destruction. How long can anything survive on Venus? By the time the first images arrived, one truth was undeniable. Venus does not allow visitors. It tolerates them, briefly. On Earth, machines fail because of time, wear, or mistakes. On Venus, they fail because physics itself is hostile. The surface temperature stays above 460 degrees Celsius day and night, hot enough to melt lead, hot enough to destroy most metals used in electronics. And heat was only half the problem. Venus's atmosphere presses down with 90 times Earth's pressure. Standing on Venus would feel like being nearly 1 kilometer underwater, without the water to carry heat away. Every seal, every joint, every wire, all under constant crushing force. The Venera landers were built like pressure safes. Thick titanium shells, minimal moving parts, electronics packed inside insulated spheres. Even then, survival was measured in minutes. Venera 13 holds the record, 127 minutes on the surface. That is still the longest anything human-made has ever survived on Venus. Why so short? Because cooling is impossible. On Mars, probes lose heat to the air. On Earth, heat escapes naturally. On Venus, the air is already hotter than the machine. There is nowhere for heat to go, so internal temperatures rise until circuits fail silently. Scientists tried everything: better insulation, simpler electronics, shorter mission goals. But Venus always wins in the end. Modern probes don't even attempt long landings anymore. Orbiters study Venus from above. Radar maps its surface without touching it. Balloons have been proposed to float high above the deadly ground. The surface itself remains off-limits. Venus teaches a harsh lesson. Some environments are not meant to be explored the way we explore others, not yet. To survive Venus, technology itself must evolve. The future of Venus exploration. After decades of failure, one question remains. If Venus destroys everything that touches it, why do scientists still want to go back? Because Venus may hold answers Earth cannot. It is nearly the same size as Earth. It formed at the same time. Yet it became something completely different. Understanding Venus is not about curiosity alone. It is about understanding planetary fate. Instead of fighting Venus directly, scientists are changing strategy. The first shift is altitude. At around 55 kilometers above the surface, Venus becomes surprisingly calm. Temperatures are similar to Earth's. Pressure is manageable. This is why future missions focus on floating platforms. NASA and other space agencies have proposed aerostats, balloon-like probes that drift in Venus's upper atmosphere. From there, instruments can study chemistry, winds, and clouds without being destroyed in minutes. Some concepts could survive for weeks or even months. Another breakthrough may come from materials science. Researchers are developing high-temperature electronics that can operate without cooling. Silicon carbide circuits, mechanical computing concepts, no fragile components. If these technologies mature, surface missions may return. Venus is also back on mission schedules. New orbiters are planned. Atmospheric probes are being designed. Radar mapping will become more precise than ever before. The planet is no longer ignored. The goal has changed. Not to conquer Venus, not to colonize it, but to listen to what it tells us. Venus is a warning. It shows how a planet similar to Earth can become unlivable through runaway change. In studying Venus, we may be studying our own future. If Earth and Venus started the same way, what truly decides which worlds survive? And how close are we to that line?